Hello everybody. Today my friends and I will be explaining the technicalities and working of direct memory access, an important part of computer architecture that greatly increases speed of operations. Normally, there are three main techniques used by input-output devices or I/O devices. The first being programmed I/O, where I/O occurs under direct control of the program. Second being interrupt-driven I/O, where a program continues to execute input and output until it is interrupted by corresponding hardware to signal the end. And lastly, we have direct memory access, which we will now explain in detail.
Firstly, let's understand the problem to get a better understanding of need of DMA controller. To provide memory access to the input-output devices, we need to first interrupt the CPU and ask for a permission. Then the CPU will further process and grant the memory to I/O. As this is a two-cycle process, it is very time-consuming. Here comes the role of a DMA controller. It will provide direct connection between input-output and the memory without interrupting the CPU. Now we can access memory in only one cycle. This will reduce the time consumption. Hence, this is the need of DMA control.
There are three types of DMA controller registers. First one, address register, second one is word count register, and third one is control register. So address register contains the address to specify the desired location in memory. Word count register contains the number of words to be transferred, and control register specifies the transfer mode. All registers in DMA appear to the CPU as input-output registers. Therefore, the CPU can both read and write into DMA registers under the program through the data bus.
DMA controller and its working. Whenever an input-output device wants to transfer the data to or from memory, it sends DMA request to DMA controller. DMA controller accepts this DMA request and asks CPU to hold for a few clock cycles, and it sends the hold request. CPU receives the hold requests from DMA controller and relinquishes the bus and sends the hold acknowledgement to DMA controller. After receiving the hold acknowledgement, DMA controller acknowledges our input-output that data transfer can performed, and DMA controller takes the charge of system bus and transfers the data to or from memory. When the data transfer is accomplished, the DMA rises and interrupts to let know the processor that data transfer is finished, and process can take control over bus again and start processing where it has left.
Input and output devices access the device's memory through the CPU, which means that each cycle takes a long time. This results in a device being slow. With the introduction of DMA, I/O devices can access memory directly without CPU involvement. This increases the speed of operations.
Thank you for watching this video and being with us until the end. If you enjoyed it, please give us a thumbs up. Also, feel free to leave a comment below and let us know your thoughts. We students at VIT were glad to provide you with the knowledge of direct memory access controller. Bye bye, take care and have a great day.